Okay, the first thing I'm going to do today is review about the exponent rules. There's basically 4 that we went over to make sure that you know. The first one has to do with multiplying. When you're multiplying these, all you really have to do is keep the base and add the exponents. So this is going to be a to the 10th power. Okay, so when you multiply, you add. Right here, this is division. When you divide, you actually subtract. So you're going to have a 3 minus 2, which gives you a to the first or just a. A good way to remember this is if you were to write it out and have AAA divided by AA, the reason why it is a single A is because of that right there. They cancel each other out. The other one is the 0 exponent rule. Anything to 0 is 1. Okay, it doesn't matter what it is, unless there is a difference between a -6 and then a -6 in the parentheses. This first one is -1 because the base is 6. The base is -6, so it's just a regular 1. And then the last one we went over was whenever you have a negative exponent. Okay, a negative exponent is kind of like whenever you solve an equation and you have negative x equals 5. That's not something you want to end an equation with. You want to change that to x equals -5. So you just flip both of them. Same thing goes true with exponents. This is really the same thing as 7 -2 over 1. So you flip it and make it positive. So now it is 1 over 7 squared, or you could say 1 over 49. Same thing here. You're going to flip it and make it positive. So again, you flip, make positive. Okay, we're going to do a few little examples just to kind of help you out. Here, whole number to whole number, 2 times 2 is 4, and m squared times m to the 3rd, you add, so that's m to the 5th. Here, again, whoops, that was a bad parentheses, sorry. Okay, here you say 4 times 2 is 8, and then r to the -3rd and r to the 2nd, you add, so -3 plus 2 is r to the -1. You don't want to have a negative exponent. You leave 8 there and put r on the bottom and make it positive. Here, it's just 2 times nothing, so you have 2, and then you say 4 plus -3, which is 1. 4 times 2 is 8, n 4 plus a -3, or 4 minus 3, which is 1. Here, again, you're going to do 4 times 3, which is 12, 8a, and -4. So you do 3 plus -4, or 3 minus 4. B is b squared plus or minus -3, however you want to say it. So your final answer is going to be 12a, -1, b, -1. Now again, you don't want to have negative exponents, so your final answer is 12 because it's positive, and then you have a to the first, b to the first, and that goes in the denominator. Or it should really be 12 over ab. Okay, next one. Anything to the 0 power is 1. You're going to take this -4 and distribute it to everything. Okay, so that means everything that's here goes on the denominator, and it's going to be 2x squared, and now that's going to be 4, which is actually going to give you 1, 2 times 2 times 2 times 2, which is 32. Power to power, you multiply, and you have that. Okay, just a couple more. Division, you subtract. This is imaginary 1 there, so you have 1 over 2. 2 minus 3 is a -1. And where it's going to go is down here, and it's going to be positive. Okay, so if you were to just write this out, let's go back and do this again. Let's just pretend like we didn't know the rules and we did it old school where you just write it all out. What you would actually have is these r's would cancel out, and you would be left with that same answer of 1 over 2r. This right here, because this is negative, you're going to go ahead and flip it on the bottom and make it positive. So what you really have is 1 over 4x to the 5th, because that's 4 and 1. You multiply, so you add. 3 divided by 3 cancels out, and 4 minus 3 is 1. Here, this is an imaginary 1. These two cancel out, so you actually have 1/2. Okay, and then this one is probably the most complex one on this page, but it's not too bad. This 4 divided by 3, you leave it like that, so you can't really do 4 divided by 3, so you just leave 4/3. Then you say 4 minus 2, which is a positive 2. 3 minus 1. And then 3 minus 4 is a negative 1. So instead of it being here, we're going to take that out and put it on the bottom. I hope this helps you, and we are going to do more practice with it, but just to kind of give you an idea, if you need to rewatch this and understand that these exponents are the basis for everything we're going to be doing from now on. Thank you.